Welcome to the ninth lecture for AC 1002. This lecture introduces some detail into the platform frame system, which forms the majority of the timber framework in Scotland. It's currently being made, so where you see Stuart Milne houses or Barrett houses or Wimpy houses, in Scotland, around Aberdeen, they tend to be platform frame houses. So, as it's the most prevalent form of framing, that's the framing system that we'll be looking at in detail during this module. So, platform frame is a development of, and it's quite similar to balloon framing, as described in the history lecture. It consists of small timbers, regular sized timbers, set closely together with a floor which is built as a platform at each level. The balloon frame, if you remember, had full height timber studs which went from the ground to the eaves when the floor was set into that. Platform frame is different. We're forming a platform with each level. So, platform framing grew out of a need to build buildings quite quickly and use a workforce which was less skilled. So rather than using skilled joiners to create large framing members and connect them together with complicated joints, the advent of regular sawn timber, so we could get it at a regular size. If you wanted 2" by 4". You could buy lengths of that because it was being sawn, and metal fixings such as nails or angle brackets or straps. This allowed frames to be built cheaply and quickly. The system came to Europe from America, where it was used to build significant tracts of houses, and was adopted by firms in Germany, Poland, Denmark, and the UK. So, from the previous slide, the image looks quite complicated. So, why would we use this? And there's a number of benefits for timber framing or platform framing. We can start to explore building wall panels off-site. We can build them in factories, which can give us faster construction and therefore faster completion. We can deal with quality better if we're building them off-site, and we can make better use of the materials that we are building the frame out of. Currently, one of the largest framing builders in Europe, I think, is Stuart Milne in West Hill, and they will build almost an entire building as a flat pack frame system in their factory at all times of the year, ready to be shipped out on site. So prefabrication is a significant factor in timber frame and a significant factor in the Scottish construction industry. Timber frames have a low dead weight compared to masonry construction. So if you think back to the structures lecture where we're talking about dead loads as the weight of the building itself and all the permanent fixtures, timber frame is going to be significantly lighter than a masonry construction. So therefore we can design foundations to be more efficient, use less material, because the loads coming down to the foundations are going to be less. Timber frame is a dry construction. We're using lengths of timber, we're nailing them together or bolting them together. There's no mortar to be used. So compared to masonry construction, we have a reduction in wet trades. Wet trades are trades like plasterers, masons, builders who have to use water within mortar or plaster or render which has a drying time associated to it and has some restrictions regarding the weather. For instance, you can't use mortar, or you shouldn't set mortar where there's a risk of it freezing, whereas a joiner can work in all weather. You can work in the snow and still the nail gun will fire and you can erect the frame. It's also possible to get high levels of insulation within a timber frame, um, and the diagrams to follow will show how that's done. But it's easier to get insulation without having to get a very thick wall by using a timber frame. So at its most basic, a platform frame is a way of building buildings in one level at a time. So you would use a regular height wall panel onto which a floor can be installed, and then the next floor would be built up off of that platform, and so on and so forth until you reach the desired height. It's suitable for low-rise buildings, regularly used for houses of 1 to 3 stories, and it is possible to build up to 6 or 7 stories. And the wall frames are usually made from small cross-section timbers, usually about 150 by 50 millimeters, or thereabouts, and they're spaced between 400 millimeters and 600 millimeters apart. The significance of the 400 and 600 is that it's a division of 1200, and sheathing panels tend to be delivered in 1200 by 2400 sizes. So if you have your studs spaced at 400 or 600, then you know that you can install sheathing panels without having to cut them. And it's a throwback to old imperial measurements. 600 millimeters is 2 feet. The floors are formed using timber beams, which we would refer to as joists, which are single pieces of timber usually, or they can be composite, and they tend to be spaced at the same spacing as the studs, so 400 or 600. Their depth for floor joists tends to be deeper than wall studs because they have to span a greater distance, so there's a possibility of deflection. If you refer back to the structural lecture where I was talking about bending, the possibility of a joist bending relates to its cross section. The deeper it is, the less that bending will cause the ceiling to sag. And if a joist does sag, then ceilings will crack and decoration will suffer. So they tend to be slightly deeper depending on the span. So we look at a component at a time. The bottom part of the timber kit or the timber frame or the platform frame, and those 3 terms are usually interchangeable, is the sole plate. This is really the kind of first thing that allows you to then build your timber frame off of that. It gives a solid base through to the substructure, and it also allows you to nail studs to it. So it's the kind of the lower member of the wall framing panel. If the sole plate's installed to the top of substructure walls, there's usually a DPC installed underneath. And from the previous lecture, and we'll go on to talk about this again and again and again, I'm afraid, the DPC is a damp-proof course, which is a plastic membrane which is installed underneath the sole plate, and it prevents moisture from the ground or the substructure from reaching that sole plate. The vertical elements of the timber frame are referred to as studs, and as I said, they're spaced at 600 to 400 millimeters, and the studs are consistent in height. They tend to be 2.4 meters for a developer built house. They can be slightly longer for specialist houses or one-offs, and their primary purpose is to carry the load from the floor above or the roof above vertically down to the substructure and therefore down to the foundations. On top of the studs you would find a top plate. Top plate is the upper equivalent of the sole plate, so it's the kind of opposite side of the frame, if you like. And from a structural point of view, the top plate ties the studs together into a single frame and allows loads coming down from above to be distributed to the studs. Normally the top plate is doubled, so you would have two of them, and you would overlap the joints, especially at corners where it might be quite difficult to tie those together, but the two top plates would allow a corner junction to be formed where one sits on top of the other. And onto that we would install a header joist, so the joists being the elements that span from one side of the wall to the other to form a floor. The header joist would be the same depth as them. It sits vertically on top of the double top plate and creates the kind of back of a shelf or a pocket into which the joist can be installed. I think if you've got to lecture 9, you're probably thinking that every single lecture I'm talking about mentions racking, and this one's no different. It is a problem that needs to be solved with timber framing, and the primary way to solve racking or prevent racking in a timber frame is to install sheathing boards. So that would be OSB, which is oriented strand board. Looks like big chipboard, or it could be plywood, and these would be nailed to the face of each stud. And as I mentioned previously, they tend to be sized at 1200 by 2400. It's actually 1220 by 2440, and that allows them to be placed up against regularly spaced studs and nailed through at each edge and down the middle. Primary function of sheathing is to prevent racking, but it also allows you to fix membranes to it. And when we go on to the talking about construction layers, there are membranes to the outside that need to be stapled onto something, and sheathing gives you another, it gives you a good surface to do that to. The red line on this diagram represents diagonal bracing, and that is an option, not often used in Scotland. We tend to use sheathing as our racking prevention. And the advantage of timber framing with regard to thermal performance is that there is space between each of the studs. It's not a solid wall. So we have a regular space of just less than 600 millimeters, and by the depth of whatever the stud is. So if they're 150 millimeters, you can fit 150 millimeters depth of insulation into that space. So that can give you improvements in thermal performance without requiring additional depth within the wall. Because of changes to the building regulations and improvements year on year, and usually every year they ask for a better performing building to be built, nowadays it's very difficult to actually get sufficient insulation into that space to meet the building standards. So we tend to install it between the studs and install it either inside or outside the studs. And the platform in the platform frame name is installed using timber joists, and these sit onto the pocket that I described, with their back going into the header joists. And the joists are like floor beams. They're deeper than studs, 195 millimeters or deeper, sometimes up to 300 millimeters before it starts becoming uneconomical to use a solid piece of timber. And they're spaced to suit the span, 400 millimeters to 600 millimeters. Sometimes the joists are installed using a metal component called a joist hanger. Um, there will be a separate lecture comes up for that, but if I can find a picture, I will flash it up on the screen round about now, so you can see what it looks like. And it should be a metal component that has a pocket, a number of nail holes, and you can install this um, to the header joist, and then the little shelf or pocket allows the joist to be sat into that and then nailed home. So to get to another level, to increase the height of your building, we've got as far as producing a platform using our joists, and really the simplicity of the system is that we can install another frame directly on top of it. So to create another frame, we would put down a new sole plate, studs, a double top plate, and there we've got another frame on top. And of course, if we are prefabricating these, the framing elements, including the sole plate and the double top, can be installed in a factory, and these things can actually just be dropped on as soon as the platform's completed. I said before that you could get up to 7 stories. It's probably possible that there are buildings taller than that, but there are difficulties involved in building tall buildings using platform frames. When you install a piece of timber horizontally, it is more susceptible to shrinkage across its depth. So timbers tend not to shrink across their length because that's the direction that the the grain of the timber goes in, but across the grain timber will shrink. So if a 50mm piece of timber shrinks by 5mm, and for each level you have a sole plate and 2 top plates, that's 15mm per level. As soon as you get up to 10 stories, that's 150mm, which can cause significant problems with things like stairs to different levels, attaching windows. So there can be significant drops from the top story downwards. And the last examples that we looked at were kind of simplistic. They didn't have any window openings, and we need to kind of do them because we have to see out of buildings and get into buildings. And most of our openings that we create will need some kind of structure over the top of them. So in this example here, at the upper level, we have a stud which is exerting a force downwards to that point, and that force needs to be able to continue down. Where the other studs are, there is a stud directly underneath them, so it kind of makes sense to that this stud here can carry the load from above. But where we've got a window, we don't have a stud underneath it. So we would install a lintel. So the orange thing on your screen is a lintel, and it's kind of like a beam that goes over the top of a window. And that beam needs to be supported at either side. So we have a short stud, which is sort of cut off at that point there. It sits directly underneath the lintel and is fixed back, nailed back to the full height stud at either side. And these shortened studs, which you sometimes find under windows as well, are kind of cruelly called cripple studs because they've been cut short. So you'll find cripple studs underneath windows, at the side of windows and doors to carry the lintel, and over the top of windows if the windows don't go full height. One issue that you will come across is that depending on where you are, things will be called different names, which can be confusing and not very helpful to you. You'll find that in different parts of the UK we have plates for horizontal piece of timber. in other parts they're called rails. Sometimes we don't have a double top plate, we have a head plate and a head binder. Most of these things are the same thing. The word lintel, I consistently spell it with an O, and my spell checker consistently tells me it's got an E. So there are regional variations regardless of where you go, and I'm afraid you're just going to have to deal with that. There are small timbers that fit between studs that are sometimes called dwangs and sometimes called noggins. And you do sometimes find all sorts of odd phrases depending on where the builder's from and whereabouts you're operating. But you'll get used to it, and it's kind of fun to collect these things. So, in conclusion, platform framing is a method of creating a structure which allows you to use regular length timbers of a regular sawn size and make them into standard size wall panels that are able to be made in a factory, and they then support a platform above that, which allows you to build additional levels from it. There are a couple of aspects about platform framing which you will use throughout your career if you stay in Scotland or work in North America or work in England or Europe. And you should probably make yourself familiar with the names and functions of each of the basic components, the methods by which racking is prevented, the method by which a second floor is added or a subsequent floor is added, and the method by which an opening can be formed. So that's the end of lecture 9. If there are any questions, as always, just ask me in the workshop. Okay, thanks, bye.